Alright guys, today we are doing lesson 3.6 and 3.7. They're very similar, so that's why I decided to put them together, because we do have some extra things that we have to learn this year compared to the standard class. So in lesson 3.6, your objective is to graph quadratic inequalities in two variables and solve quadratic inequalities in one variable. In lesson 3.7, our goal is to graph systems of inequalities in two variables. So basically this one is graphing one graph, this one's graphing two. You have done this in Algebra 1, so this beginning part should be hopefully part of a refresher, but if not, I will take it slow. So here's your key idea right here. So graphing an inequality in two variables. Step one, you're going to graph the parabola in standard form, make the parabola dashed for inequalities with this, so less than or greater than, and you're going to make it solid for inequalities. So this is something that's similar to the circles. So we have a dashed line for these inequalities, and we have a solid line for those inequalities. So kind of similar to the open circle, closed circle. So remember, closed circle was or equal to. So or equal to is solid because it does include those points. All right, so once we do that, then we're going to test a point that does not lie on the parabola. So a point above it, below it, outside of it, somewhere that's not on the actual line. And then based on that test will tell us what part to shade. So the difference between this one and Algebra 1 is you graphed linear equations. In this one we're doing quadratic, but by now we should be becoming professionals at graphing quadratic functions. So we have a quadratic function in standard form. This right here tells us which direction our graph should open. So that's something you need to look at right away. This tells us it's going to open down, because some of us are still getting that part mixed up. So starts with a negative, opens down, does not have a negative, opens up. Okay. So now, if you think you are a professional at graphing quadratic functions, please pause the video and actually give it a try, just to see how it is. Just plot your points and come back and we'll talk about the rest. Okay, if you don't feel that you're ready to graph on your own, that is fine, I got your back. All right, so when we have a quadratic function, we do not know our vertex. We do know something though. We know that this right here is our y-intercept. So we do know that on this graph at -1 on the y-axis, we have that point. All right, so we got 1 point so far. Now we need to find our vertex because we need to know where our highest point is, because remember it's going to be a maximum since it's open down. So remember, we do, to find the x value of our vertex, we do -b over 2 times a. All right, so -2 over 2 times -1. So remember, if there is none, there is 1. There has to be 1 for it to exist. So this becomes +2, this becomes -2, which equals -1. So that is the x value of our vertex. So right now we know -1 comma something. So how do we find that something? We plug it in. All right, remember, you can find any y value by plugging in the x value. So we plug it in. All right, so we are going to plug in -1 for our x's. I'm just going to draw a line there so it doesn't get mixed up. So we have -1 squared minus 2 times -1 minus 1. Guys, if you do not put this in the calculator properly, it's going to not give you the right answer. Remember, I put parentheses around this because I'm squaring the entire thing. So when you put it in the calculator, you have to do it the same way. So -1 squared gives me +1, but I still have a negative right there. Then -2 times -1 gives me +2, and then I have a -1. So -1 plus 2 minus 1. So -1 plus 2 gives me a +1. +1 minus 1 gives me a 0. So our vertex is -1 comma 0, not to be confused with 0, -1. So -1 comma 0. So this is our vertex. So remember, because we know that axis of symmetry cuts through here, I have a point here, I also have a point right there. So you could come up with some more points if you want to make your graph bigger. So maybe like 2 would be a good one, or 3 to test. I'm going to do that and come back just so we can have a more accurate graph. So I'm just going to plug in 2 for x. So if you want to pause your video and do the same, and then come back and see what our y value is. Okay, so I kind of did the work right over here. When x equals 2, I just plugged in 2 for each one, and I got -9. So this is another point on our graph, 2, -9. I just did it to the side because I didn't have a whole lot of space. I didn't leave a lot of space to make these 2 pages. All right, so what does that mean? That means now I can go 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I know there's another point here. Again, the axis of symmetry comes into play. 1, 2, 3 away, so 1, 2, 3 away. Now, is our line dashed or solid? So if I look at this, this tells me that my line is dashed. It is not or equal to. So now instead of drawing a solid line, I'm just going to draw a dashed line going all the way down to infinity. So with inequalities though, remember it's not just one number, it could be a multiple of numbers. So in this case it's telling us y is less than these. So sounds like we're going to shade this inside. Okay, but to be 100% sure, we can do step 2 and test a point. So remember, it says that does not lie on here. So I personally like zeros. So let's pick a point on the graph that has a 0 with it. So like this was -1, -2, -3, -4. Let's go with this one. So let's test this point. So our test point is going to be, I'm going to put it up here. We're going to test 0, -5. So how does this help us? If we test this point, and this is a true statement, so we plug it in, we get a true statement, that means this section is shaded. If we plug it in and we get a false statement, that means the other section is shaded. So let's look. So we're using this equation right here, our inequality. So we're gonna, this is our x value, this is our y. So we're gonna say, let me use a different color so it doesn't mix up. So we're gonna say -5, is it less than -0 squared minus 2 times 0 minus 1. So all I did was plug in -5 for y, 0 for x's. And now we're just going to solve. So -5, is it less than 0 minus 0 minus 1? So -1. Is -5 less than -1? It sure is. So what does that tell us? That tells us then that this is a true statement. So this whole section is possibilities. So any point we pick in this section here that we've shaded is a solution. All right, so this is our solution. So any parts on here make a true statement. Sorry, I was doing laundry. So this is our solution. This is your answer. If this would have not been true, we would have shaded everything else. But these inequalities do kind of help you because y is less than. So where are the y values that are less? Below. I just say test it just in case, or if you second guess yourself, always test the point. You can do it in a calculator. You can do it quickly in your head. You don't have to write it out. All right, so I'm going to give you 2 to try. I did give you a sheet of graph paper that looks like this. So this is where you're going to do your self-assessment questions. All right, that way you can graph them. So I would like for you to try these 2. If nothing else, at least try to graph them, and then we'll come back and test a point and see what part to shade. All right, so please at least try to graph it. All right, look at, does it open up or down? Should your line be solid or dashed? Those kind of things. All right, once you have it graphed, please unpause the video and let's check it out. So if you got this far, just note that because this is -8, we found our vertex to be -9. You are going to need to count your y values by 2's. So I made a note of that here. It is not necessary to count your x values by 2's because our vertex is -1. Had it been a larger number, then you could do it. Remember, you can make this graph your own. So they may have, the one I gave you, does it have more? Let's see, maybe I should have did it on this one. Actually, you could have did it on this one. 1, 2, 3, 4, 5, 6, 7, 8. So maybe I should do mine on this one too then. I'm going to come back to this one then. I just had those there. Just quit listening to my rambling. All right, I'll use this one. That way it's the same as yours. Okay, so I did the work on this paper. So I got the vertex 1, -9 by doing our negative b over 2a. Gave me -9. Then I decided to choose a point that was close to the vertex. So since our vertex was here and these points were a little low, I decided instead of doing 1 to try 2. And when I plugged in 2, I got 0. So now again, because of the axis of symmetry, this one's 3 points away, so I knew there was another one there. All right, so here is our inequality. Should our line be solid or dashed? So because this is or equal to, we may have a solid line. It is opened up. So we can go ahead and graph this with a solid line. Now we need to know which part to shade. So because it's y is greater than, I'm going to assume we're shading this inside part, but we're going to test it to make sure. Now, here's my favorite point to test right here, the origin, 0, 0, because it is not hard to work with zeros at all. So let's plug in 0 for y, 0 for x, see what we get. So does 0 or is 0 greater than or equal to 0 squared plus 2 times 0 minus 8? So we know these are all going to cancel out. So basically we're saying is 0 greater than or equal to -8? And we know that it is. So we definitely are shading this side. Oh. I forgot to mention that you may want two different color pencils, color pencils for when we do the later examples as well. All right, so if you will, go ahead and pause the video again if you did not try the other one yet, and I'll come back and put it here. Okay, so the vertex for this one is ugly. Remember though, if you don't like fractions, you can turn them into decimals. This would be 0.25. This would be negative 0.125, or actually not 0, but negative 1.125. So again, if you don't like the fractions, you can put them in the calculator. You can get the decimal form. Okay, so go ahead and graph this. So we have 1/4 is going to be not all the way. If we wanted to, we could count these by halves to make it not so tiny. So we could go like 1/2, 1, like 3/2, 2, and so on. Remember, this is your graph. Oh, I'm plotting on the wrong one. Let me go back to this one. Sorry, my bad. So our vertex was 1/4, -1 and 1/8. Sorry, I forgot I was doing it on this one. All right, zoom out. Okay, so we've got that as our vertex. So again, this one you could do, like, count these as halves. So you could do like 1, 2. You don't even got to write the halves. Just make it like that if you want. Okay. Then you could do the same going down. So you could have like -1, -2, and so forth. All right, so we got 1/4 is going to be halfway in between 0 and 1/2. And then we're going down 1 and a tiny bit of it. So I'm just going to put it there. It doesn't have to be exact. That looks pretty good. All right, if you did not test another point to find, or plug in another point to find it, try 1, and we'll come back. All right, so if you plugged in 1, you get 0, so we do have an x-intercept. There was a point that we did not graph yet, or I didn't graph yet. Maybe you did. The y-intercept of -1. So here's our axis of symmetry. So our other intercept be over there. Nope, that don't look right. I think it would be, that one's going to be kind of funky. So that one's going to be at the half mark. So it would be right there because that's -1/2. -1/2. All right, so solid or dashed line, you should have said solid line. And now we're just graphing. All right, where do we shade? Do we shade here or do we shade here? So it does say y is less than, so I'm assuming we're going to shade here. So we haven't tried one where we got a not true statement. So let's do 0, 0 and see what happens. So we're going to test 0, 0 into this inequality. So I'm going to say, is 0 less than or equal to 2 times 0 squared minus 0 minus 1. So we're plugging in the origin. So is 0 less than or equal to -1? And that's not a true statement. So that means we do not shade that area. We're going to shade everything else. So that means we're going to shade all of this. So everything not inside the graph. I guess this green isn't that good. I was just trying to be colorful. So everything not inside the graph would be shaded. And that would be your solution. So any point in this area would be a true statement. All right, I'm going to stop the video there. We'll come back and talk about solving algebraically. Like one. All right, when determining which region to shade in the graph of a quadratic inequality in two variables, why is it important to test a point that does not lie on the parabola? So write your answer to this and turn it in when you're done with these notes.